So here are a few things that you need to remember every time you factor. We have the general form here of ax squared plus bx plus c. A is a 1, b is negative 12, and c is negative 28. Whenever your a is a 1, factoring can be very easy for you. So all you have to do is take the factors of negative 28. So that means what times what equals negative 28. And you can go through the list and write them all out if you want to. And because it's negative, it has to be one of them negative. 2 and 14. 3 does not go into it. 4 and 7. And if you're having trouble finding the factors of this negative 28, just type in your calculator negative 28 divided by 2. There it is, negative 28 divided by 3. And keep going down the list until you come to one where there's really no room. I mean, if we do 5 and 6, there's no way. So now that we have all the factors, we have to figure out which one of these sets of numbers are going to add up to our negative 12 over here, which is our b. So negative 1 and plus 28, definitely not going to add up to negative 12. So these two are out. Negative 2 and 14. 14 minus 2 will give you 12, which is positive, but we need a negative 12. So does 2 minus 14 equal negative 12? Yes, they do. This is the right answer right here. So these are the factors that we're going to use. And when you factor, we're going to set up 2 sets of parentheses. Remember the FOIL method or the box method? This is where that comes into play. What we're doing is we're undoing this equation over here to look like 2 binomials. So we have a positive 2, we'll just throw that in, and a negative 14. And it does not matter what you put first. You could put the negative 14 here and the positive 2 over here. It does not make a difference. Now if we wanted to, we could always go back through and check our work. So the FOIL method would be x times x, which is x squared, negative 14x, positive 2x, and negative 28. And when you add the like terms in the middle, we have negative 14 plus 2, which is negative 12. We come up with the same exact thing they told us to factor. And that's what we want. So x plus 2, x minus 14, that is your answer when you factor. So I'm going to erase this out so you can see the answer. Oops. So there's the factors of this quadratic function. Let's go ahead and try another one. Again, you always want to start by looking at your a. We can see here that a is 1. Factoring is going to be easy. So we're going to take the factors of negative 16 and we're going to figure those out. So 1 and 16, 2 and 8, 4 and 4. And the reason why I don't do another 4 and 4 because it really doesn't matter. This is going to be the same. So now we need to figure out which pair of these numbers are going to add up to our middle term, which is negative 6, or our b. So negative 1 plus 16, not going to happen. But these two possibly will add up to negative 6, depending on which one we choose. So 8 minus 2, that'll give us positive 6. So it's got to be this one. And all we do is put our 2 sets of parentheses. We're going to form 2 binomials. Plus 2, negative 8. Okay, and for this this is the answer. That is factored. Now to check it, I'll do the box method for those of you who like that as better. So we're going to put x plus 2, and then x, and then minus 8. So we multiply these two together, multiply those two, negative 8x and negative 16. Okay, and what you need to do is write your x squared first. You add these together, which will give you negative 6x and negative 16. And you can tell that this quadratic function matches the one they gave us, so we did it correctly. Now, when you have a quadratic function where your a is no longer a 1 and it's a number, this can be a little tougher. So here's a shortcut that I've been able to use, and it's worked pretty well in the past. What you're going to do is, yes, you're going to take the factors of your c, which is 10, but before you do that, you're going to take the factors of 3, or your a. So the factors of 3 really is just 3 and 1. And now right underneath of it, you're going to do the factors of 10. And you're just going to pick some. So first thing that comes to mind when I think of 10 is 2 and 5. So I'm going to put 2 and 5 right underneath of it. And what you need to do now is cross multiply. So 1 times 2 is 2, and 3 times 5 is 15. Now, in order to tell whether we're going to get this negative 17 in the middle, we have to add these. And you can tell we get positive 17, not negative. So if we fix this, we still use 3 and 1, but in order for 2 and 15 to ever add up to negative 17, they both had to be negative. So let's change negative 2, or 2 to negative 2, and 5 to negative 5. And we'll see if that works. Again, cross multiply. So we have negative 2. 3 times negative 5 is negative 15. If you add these together, we do end up getting negative 17, which is the middle term. Okay, so we finally found the factors that we need, but it's a little different to set them up. I find that circling them like this will help you. So we're going to set up two binomials just like before. But instead of being x and x, it's going to be 3x minus 2. And 1x, which is just x, minus 5. Okay, so there's the factors. And again, you can go through and check these to make sure you did them right. So 3x times x is 3x squared. 3x times negative 5 is negative 15x. Negative 2 times x is negative 2x. And negative 2 times negative 5 is positive 10. And the only thing you have to do is add the like terms in the middle. And you compare over here. Do we have 3x squared minus 17x plus 10? Yes, we do. So we did it correctly. We're going to try another one of these just for practice. Okay, first thing you always do when you're factoring is look at your a. And you can tell right now that a is not 1, so you just can't take the factors of c and call it good. You have to take factors of a and c. So let's do that. So the factors of 5 and 1. And directly underneath of it, you're going to do the factors of 20. And you can just pick one, whatever one you want. Let's do 2 and 10. Okay, and then you are going to cross multiply. So 1 times 2 is 2. 5 times 10 is 50. And And if you add these up, will you get 29? No, you get 52. So what I would do is I would switch the 2 and 10 around. And now we can cross multiply again. So 1 times 10 is 10. 5 times 2 is 10. And if we add these up, we're getting closer, but that only gets us 20, and we need 29. So 2 and 10 maybe are not the right factors of 20 that we need to use. So let's try a different one. I'm going to try 4 and 5. Okay, so cross multiply. We have 25 and 4. If we add those up, we finally get 29. Okay, so we found it. And this is why this one takes a little longer. So when your A is more than 1, it'll take a little longer to find out the factors. Okay, so we found it. Remember, you go down when you set this up. So 2 binomials, we have 5x plus 4, and we have 1x, or just x, plus 5. And there it is. Those are the factors of this quadratic function. I'm not going to go through and test this and check it. I'll leave that up to you, just for the sake of time. All right. Lastly, we have special factoring patterns that make it a little more easy for us. And this goes with if you have 2 numbers here that are perfect squares, meaning you can take the square root of each one, then there's a pattern. And it's a plus b, a minus b, every single time, no matter what. And this is called the difference of 2 squares. So for example, I have x squared minus 9. Can you take the square root of an x squared? Well, yes, you can. It's x. Can you take the square root of 9? Yes, 3. Because there is a minus sign here, it follows this pattern, a squared minus b squared. So when you form your factoring over here, your factors, you have 2 binomials. You'll take the square root of this one, which is x, put it there, the square root of 9, which is 3, you'll put it there. Put a plus and a minus, and you're done. You don't even have to really go through and find the factors of it. So we're going to try a couple of those. So if you look at the first example here, we can take the square root of x squared, which is x. And we can also take the square root of 36, which is 6. And because there's a minus sign, all we have to do is put a plus, minus, put the x, and put the 6. And it's done. Okay, if you go to the second one, can we take the square root of 9x squared? Yes, you can. It is 3x. We're taking the square root of 9, and we're taking the square root of x squared here. And the square root of 121 is 11. So again, 3x, 11, 3x, 11, put your plus, minus. It doesn't matter if you put the minus here or the plus there. Now, if this were a plus sign right here, we would not be able to follow this pattern. We would not be able to factor it. Okay, so down here we have the minus sign, so we're good. Can we take the square root of 4x squared? Yes, that's 2x. Can you take the square root of 64? Yes, that's 8. So you set up your 2 binomials, put the 2x, put the 8. And last, put the plus, minus. And you factored it. All right, and the very last thing we're going to do is called the zero property. And what the zero property is trying to get you to do is try to figure out on the graph where the zeros are. And the way you can do that is, yeah, you could look at your graph in the calculator, but if I asked you to show the work for that, you would have to factor it first. So we're going to factor this out. So the first thing you do is look at your A. A is 1, and that's good because that makes life a little easier. So we're going to just take the factors of negative 18. Two and 9, 3 and 6, and now we have to figure out which pair of these will add up to our b, which is 3. And I know that 6 minus 3 will give us that. So those are the two factors we're going to use. You're going to throw them in your parentheses, the two binomials. So x minus 3 and x plus 6. Okay, now that you have that, we need to figure out what it's going to be when this equals 0. Okay, so we're taking this equals 0 and we're putting it on. This is asking you, what does x have to be here in order for this parenthesis to equal 0? Well, if you take x minus 3 and you set it equal to 0 and solve for x by adding 3 to both sides, x is 3. So here's one of your intercepts. Okay, same thing over here. What does x have to be here in order for this parenthesis or the binomial to equal 0? So you take the x plus 6, set equal to 0, and solve for x. So here is your other intercept. Remember, because it's U-shaped, you're going to have two intercepts on the x-axis, which is 3 and negative 6. You could put this function in the calculator and check it, and it would show up correctly. Okay, just a practice problem with this. If it says to find the zeros, that is the same thing. You set it equal to 0. The first thing you're going to do is factor it. So, look at your A. Your A is 1. Life is easy. Take the factors of 48. Okay, so we have 1 and 48. And we also have negative 1 and negative 48, because that will equal positive as well. 2 and 24. 3 and 16. 6 and 8. And again, if you don't need to go through this whole list, then don't. This is just me trying to show you every single step. Okay, so now we need to figure out which pair of these will add up to negative 14. I know these two do. So in the parenthesis, I'm going to put x minus 6 and then x minus 8. Keep it set to 0, and now we just solve it. So we take x minus 6 and set equal to 0. Add the 6 on both sides. We found the intercept. This is a 0. We found the 0. Same thing over here. The x minus 8, set it to equal to 0. We add the 8s. So we also found the other 0.